Me and Grace are going to talk about the history of plate tectonics, and I'm going to talk about how they work. So, in the early 20th century, a German scientist named Alfred proposed the continental drift theory. He suggested that years ago that all the continents we live on today were joined as one big supercontinent, and he named this landmass Pangaea.
Okay, I'm going to talk about Pangaea. There's people here now, and so if I forget my lines, I'm really, really sorry.
We practiced
so many times. So before I begin, I tried to make my little talk funny. So I searched up tectonic plates funnies, and they're not funny.
Yeah.
So I guess geological humor has its faults. So disregard that. That wasn't funny. What? Okay. That's not where the pen is. The pen is over here. Okay. So the theory that the Earth, that's my Earth, forgive me, I'm sorry. Was the theory that the Earth is broken into fragments is at least 200 years old, and scientists didn't believe it until the 1960s, when mounting evidence made it clear that the Earth was indeed broken into fragments, and these fragments, called tectonic plates, are moving. So, well, I'm gonna fall. Okay. Medina's gonna go. Thank you. Medina's gonna go farther into this, but this is the inside of the Earth. This is the crust here, this is the mantle, and obviously this is the core. So the plates float along in the upper mantle, which is the cool, slow-moving rock just below the Earth's crust. So we measure the plates' movements with millimeter precision from space, and they move anywhere from 5 centimeters to 30 centimeters per year. So to make this theory a little bit easier to understand, I like to think of it as a conveyor belt. So the plates themselves are the conveyor belt, and the continents are along for the ride. They are the baggage. Hope that made it easier. Okay. Pangaea. So yes, as she said, Alfred Wegener, a German meteorologist, came up with this theory, the most believable theory. There were many before him, but none had evidence such as he had. So Alfred Wegener, Pangaea, and the continental drift. This evidence was basically identical fossils in European and American coal deposits, suggesting that they were once joined, and also like tropical animal fossils in cold climates. Yes. And so if you look at the Earth today, the continents fit together much like puzzle pieces. Not quite anymore because of global warming. So global warming has made more ocean and taken off pieces of Earth. So if global warming continues, and when the plates move again, because they will, because they're always moving, coastal cities will be completely underwater, and Florida will be gone, and so will Vancouver. And I hope that I didn't send you home with nightmares. I'm really sorry. But anyways, that is my presentation, and on to Medina, who's gonna explain tectonics.
Like, in order to make Alfred's, well, it's a hypothesis, but in order to make it an actual accepted theory, he had one key question to answer, was what makes those continents move? But Alfred did not know that the surface of the Earth, under the surface of the Earth, there was actually slabs of rock, and those were called plate tectonics. Okay, so how do plate tectonics work? So we have the crust, and then we have the mantle, and then the core. So the core is filled with a lot of energy and radiation. So the mantle is actually rocks. It's all rock. So that radiation like melts the rock, and so the plates are moving, and so they hit, well, they collide, and yeah. That's how the birth of tsunamis, volcanoes, and earthquakes.
Woo!
Yeah.
Thank you.
The San Andreas Fault forms the tectonic boundary between two plates, the North American plate and the Pacific tectonic plate. The fault stretches from Southern California all the way up into Vancouver, so it's all the way along the west coast. And a fault is a crack in the earth where two plates meet, even though they push against each other and past each other. Faults are usually affiliated with big cracks in between plates, yeah. Yeah. Also, I also be talking about the San Francisco earthquake. So when the ground started shaking at 5:12 a.m. on April 18th, and it lasted for 40 seconds before it stopped for 10 seconds, and then it started again for another 25. The North American and the Pacific plate moved a whole 15 feet during that earthquake, and it's about the size from there to there. The event impacted more than 483,000 square kilometers in Southern California, the west part of Nevada, and even Oregon. It destroyed underground pipes, railways, and roads, and left 300,000 people homeless and more than 3,000 dead. They have estimated that damage from the quake costed in between 200 to 400 million, and 4 to 10 billion in 2014 dollars. And each dollar back in 1906 is worth $26 now. And that's it.
Our part of this project is what do plate tectonics cause, like earthquakes and volcanoes? My part is earthquakes, okay? So deep within the Earth tectonic plate boundaries, there are plates, obviously. Okay, so when the plates are always moving, like Grace said, so the plates, two of the plates will come together and they will be moving over top of each other, and then they will get stuck against each other and they won't be able to move, which is causing pressure in between the plates. So when they've had enough, they will both be trying to go opposite ways, and then all of a sudden it'll let go really quickly, and that sends pressure in all directions, which causes an earthquake. And so the plates are really, really big, like deep and everything. So wherever the pressure point is, say it's really near the bottom, that means the earthquake is not really felt and it's very low. And so when it's higher up, that's more pressure above, almost by the crust. So that sends a really big earthquake, like the Nepal earthquake. And so you can think of it like a game of tug-of-war when you and your friends are pulling on opposite ends, and then one of the people lets go on the one side and all the pressure quickly releases and goes on to the other person, and then the other person falls. Yeah. She's going to talk about volcanoes.
Okay, so under the right conditions, tectonic plates push and pull apart from each other. It forms a volcano. When magma from within Earth's upper mantle works its way to the surface, it erupts to form lava and ash deposits. Over time, after erupting, the volcano has to get bigger and bigger. Volcanoes erupt at different times. For example, volcanoes have different behaviors and times, so you would have to look at the long-term history of an eruption. When the plates come together, one of them may get pulled under the other one, getting recycled into Earth's interior. During this process, called subduction, the piece of crust getting pulled under is melted and turned into magma, the very magma that erupts from a volcano.
Okay, we're gonna erupt this pure volcano that we made together with help of Mary Rose, because she's awesome. Okay.
Wee. Ooh. Wee. Oh man. Yay. The end. We're done. Come up here. Oh my God.